Okay, can everyone hear me? All the way back to the back? Yeah? All good? Hello, everyone. How are you all? I hope you are excited to be here, as am I. I'm going to talk tonight about isomorphic React in real life and how we can use React isomorphically in our applications, which is something React enables us to do, but that I think is underused so far. So I want to tell you how we at my company were able to set up React isomorphically and what we learned and how you can do the same thing with your products. So before I start, I want to thank Red Badger for hosting this meetup, which is awesome, where we all come and learn so many new things about React and meet awesome people. And I want to thank Facebook for offering their premises for us to have this hold this meetup at. And also for writing and open sourcing React, which is awesome, which is the reason why we are here. So thanks to all you guys. Before I start, who am I? I am a front-end developer at State. And I want to show you actually what State is before I start to talk, because I'm going to talk about State. So State is an opinion network, a little bit like a social network, but where we connect people based on what they think rather than who they know. And this is our new website, which we've rewritten, or we rebuilt, and it is built with React isomorphically. So it is like a single-page application, client-side. Everything happens as you would expect in any client-side application, with things working without any full refreshes. Just like you would expect. But it works isomorphically, so if I do a full-page refresh and get a response from the server, it will put me back in it will give me exactly the same response as what I would get on the client. So we've been able to achieve that, and that's what I want to tell people, how you can get into the exact same situation yourself. So before I start, also about myself, who am I? I consider myself to be a performance tooling and open source geek. I love the web. I love sharing what I learn and helping other people to help all of us to push the web forward. I'm passionate about the web. I wrote a critical path CSS generator a while ago called Penthouse. And now I work at State. So today's talk, I'm going to talk about, first of all, I'm just going to go through what isomorphism is, what I mean by that, so everyone's on the same page. And then I'm going to say something about how React plays with isomorphism, what React enables, and what's easy and what's difficult to do with React isomorphically. And then through the bulk of the talk, I'm going to talk about how we set up our isomorphic React render flow. And specifically, I'm going to talk about how to use data and talk to an API isomorphically with React, how to bootstrap the context that you render with on the server and pass it along to the client so you can render it in the same way, and how to use something like Flux data stores isomorphically. OK, so let's get started. What do I mean by isomorphic JavaScript? Maybe all of you know this term already, but in case you don't. Isomorphic JavaScript is JavaScript, the same JavaScript running both on the client and the server. So like I showed you on that website, when everything is happening in the browser, you can navigate from page to page, and the browser takes care of rendering the UI. But when we get the response from the server for those pages, it works in the exact same way. It's the exact same code that's executed. So we write the code once, and it works in both environments. And why do we want to do this? The main reason we want isomorphic JavaScript is for performance, because it enables us to render and run single-page applications or rich applications also on the server. And you will always render much more quickly on the server than on the client, because on the client, for the first load, you will have to first download and parse all your JavaScript before you can show anything on the page at all. So you will always get better performance with isomorphic JavaScript. There's also loads of other benefits, such as graceful degradation, because if you have an actual proper DOM with anchors and semantic content in the original page response, if the JavaScript somehow fails, which it will do at some points, you have content that works on its own. Users can actually click through on links and get to the content they wanted to. It doesn't just completely die because your JavaScript fails. And there are also, because of that, because you have this proper DOM, you also get accessibility and SEO benefits in that you have stuff that screen readers and search engine crawlers can crawl and parse and understand. Even though I would say those search engine crawlers and screen readers, they get better and better all the time, so this argument is less and less important. I would say it's mainly for performance, but it has a bunch of benefits running JavaScript isomorphically. So, yeah, right. And also, Christian Hellman, who's a web evangelist, he also tweeted this recently, which I thought was funny. So we've had this flash of unstyled content where the CSS is somehow deferred, and you get this page that looks broken before the styles kick in. And we've had this flash of unstyled text where you try to use some fancy font face, and it isn't available yet when the page renders, and you get that jarring glitch, which no one likes. And now, recently, we've had this flash of client-side rendering where you see a page loaded. Maybe I can use this thing. And if it works. And it shows you these kind of, like, this is Angular specific, but it shows you a state that you're not supposed to see, which is like pre-client render. And if you render isomorphically, you would, of course, not have to ever see this. So that's another benefit. OK, isomorphic React. How does React play with isomorphism? Well, in itself, React is perfect for isomorphism, because React as a view layer comes with this render-to-string function, which allows you to, on the server, get back this very same markup that you can put into the DOM as you do get with the client-side React.render method. So React in itself has everything sorted, and it's super easy, isn't it? The problem is that there are a lot of unanswered questions. There are a lot more things that you need to take care of in order to be able to run a full application isomorphically. You need to somehow manage data fetching. You need to be able to reuse the same render state on the client and on the server. And you need to be able to handle stores, et cetera, et cetera. So this is what I'm going to talk about. But before I start, can I ask an open question? So how many people here today, can I get a raise of hands, have or is running in any kind of project at all React isomorphically today, rendering both on the server and on the client? OK? OK, that's not too bad. It's quite a few people. But I obviously want more of us to try this. I want to get numbers even higher. So let's start. I should say there's one more thing. A lot of people worry that even if it is possible to run React isomorphically or run JavaScript isomorphically in general, that it somehow comes with this cost of a massive extra complexity in that you will have to have this logic for switching between a server or client, and that it becomes unmanageable somehow. And for us at State, it just really hasn't been the case at all. And I'm going to show you how we've set it up, what our setup looks like. And I hope I can convince you that you can do the exact same thing. And complexity isn't really a big problem. So isomorphic render flow. Before I go into an isomorphic React render flow and show you how we do that, I wanted to just quickly go through a client-side React render flow so we're all on the same page. Like, roughly, what steps do you go through when you render React on the client? And do I have, yeah. So you start with a URL. You have some kind of router. The URL matches something in your routing table. So perhaps you say that, OK, for this URL, we want to render an explore page, which is a React component. So you pass it off to React using the client-side render call. And you render it into some kind of HTML element, the DOM element, so the container element. And if you're talking to some kind of API, and you have not just a static application, but something more dynamic, if you want to fetch data to display in your component, in your application, with React, you would do that in component did mount, which is one of React's lifecycle methods. And you would do something like make a GET request, and when the data comes back, you update the state inside that component. And because of the way React works, it will just re-render for you and take care of everything. And this is all quite nice. But when we're talking about rendering React isomorphically, we can't use this. So why? Because component did mount is not called on the server at all. But even if it was called, you're making an asynchronous request here. And render to string basically serializes all your components. And you just can't serialize something that's async. It doesn't understand what to do with it. If you do something like this, it would just get left out from your render to string result. So you need to do something differently. So what do we do in an isomorphic render flow? So this is a different slide. Trust me, it's not the same slide, but it looks very similar. So, and that's part of my point. The routing table is the same. We use the same router and exactly the same routing table on the client and the server. And the render function is pretty much the same. You use render to string instead of render. It functions in exactly the same way. But the difference is that because we can't fetch the data inside our React components, we need to fetch the data we need before we render in React. So we need to pre-fetch the data. And how do we do that? Well, when we first tried setting up React isomorphically, we thought that, OK, well, we have a routing table. When we have identified that we're going to render this particular page, we know what data we need. So we can just put all the data logic inside our routing table. And I guess that works. But what we found was that it bloats the routing table. It makes it just difficult to parse. Like, it just doesn't feel like that information belongs there. And it also has the side effect that you have some data logic for your components in the routing table, but you still have to manage data inside the components themselves. So you get this kind of split. And yeah, we tried it, and we weren't very happy with it. So we ended up moving those data requests back into our components. But so how does that work? Because I said that we can't serialize any async requests with render to string. So how can we have data requests inside React components? Well, it turns out React comes with this method on components, or this property called statics, where they allow you to set any kind of declaring functions or other kinds of properties which you can access on React, or sorry, on your components outside of React. Before you have rendered, you can still call your my page and use the request for props function. So it's co-located within that React component, or the page in this case, but it works to use before we rendered. So what we do is we have a method that we call request for props, which basically takes a bunch of props mapped from the URL. So we're going to render this page, and we declare what data we need before rendering this page. And the specific syntax we use here is not that important. The user provides all these things. It's abstractions on top of our API layer that allows us to declare our data requests in the same way on the server and on the client. The differences that actually exist in how we make requests does not show here. When we declare our request here, we write the code in one way, one time. And then also another point to make here is that we don't actually make the requests inside this function. This function just returns information about the request we want to make upstream to the function that calls it. And up there, we make decisions on exactly what to do with these requests that we need to make before we're going to render. So we prefetch the data, calling request for props on the page we're going to render, and that gives us data. And in the simplest possible implementation, we could just put that data in the props we're going to render React with, and that would all just work. So with using this kind of setup, you would have a full isomorphic React render flow that works in the same way, using the same parts, both on the client and on the server. But there's something missing still. We need to render with exactly the same props on both the client and on the server, because otherwise React will complain because maybe the virtual DOM will diff. Also, we just made a bunch of requests. We don't want to have to remake them on the client. We want to just pass along the exact same render context that we had on the server to the client. And if I didn't make that clear, the reason we need to re-render on the client after rendering on the server is because we need to hook up our listeners and get React to kind of like to boot React on the client so it functions as a single page application on the client. We don't get that from just rendering on the server. We need to re-render on the client after rendering on the server. So how do we bootstrap this render context? It's quite simple. So you just take everything that went into the rendering process on the server, you dump it into a JSON object on the server, and you inline it into a script tag in your HTML response. So does this thing work? Yeah. So this is not literal JavaScript. You would have to use some kind of templating language or some server language to make sure that the actual JSON object ends up inside a script tag. And if you have dumped the JSON object in the script tag on the client, you can use parse it, and you have exactly the same props available on the client as you had on the server. And that's pretty much all you need to get a full isomorphic React render flow on the server and the client functioning in the very same way. And everything is all good, except for that you might not want to dump all your data straight into React at the top level as a prop. You might find that if your data changes over time, if you cache your data, if your data models are a little bit more complicated, you might want to deal with your data in a different way. You might want to use something like Flux. But obviously, this depends on your application. If you have a very simple side project, you might not need Flux at all. But if you do, you need to set up Flux isomorphically. And how do you do that? So I don't want to go through Flux in detail here. But just as a quick overview, in Flux, you don't pass the data straight to views or components. The data goes through actions, through a dispatcher, onto stores, and then to components. The components kind of get their data through stores. So how do we set this up isomorphically? It turns out, what we found after a while, we were struggling a little bit. We tried not actually using Flux on the client server, only using it on the client and hacking things basically. But what we found in the end was it's fairly simple. The only requirement is that each of your Flux stores that you want to render or use, both on the server and on the client, they need to have 3 methods: a snapshot, restore, and a reset method. And what are these used for? So the snapshot method is used for that render context that I showed on the previous slide. Because we're no longer passing around raw data. We let our stores hold the data. And if we go through the process of putting the data inside stores on the server, we don't want to have to redo that on the client. So we basically want to snapshot and put our stores in this context object instead of the data. And with the snapshot method on stores, which just returns the internal state of the store, it's very easy to achieve. We just loop through all our stores and put them in this snapshot property on our JSON object. And on the client, we can just restore each of the stores with the data from the state they had on the server. So that's fairly simple. There's nothing magic here. It's as simple as I hope it looks. The third method that is required to run Flux stores on the server is a reset method. And this is because stores in React are singletons. So you start the stores when you start your application, and then they just live on. And on the client, this doesn't really cause any problems, cause you to think too much about things. But on the server, if you have a store that just persists its data through, until the end of time, you will run into issues with data leakage. If you have data that is specifically tailored to a logged-in user, for example, if you tailor a newsfeed or something like that to the current user, you don't want that data to be delivered again, to be reused when the next user logs in. You want it to be reset in between. So when using Flux stores on the server, if we populate them with data, we need to reset them between each request to prevent data leaking. And we do use this on the servers, on the client as well. If you have a user logging in and out, for example, you need to make sure you reset your stores somehow. So that's the store reset. And with those methods on stores, and with the isomorphic render flow, the steps that I showed you so far, with prefetching data in request for props, and using a render context object that you pass along from the client to the server, you have a full flow that allows you to run React isomorphically. You have all the parts that you do need. But I wanted to show you before I finish another step that we go through, that we use in our render flow, that made life easier for us. And it's about how we populate our stores with data, which is something I didn't say anything about yet. So basically, our stores listen for request data, and we populate them automatically. And it happens this way. The first step we go, so our data comes back from our API, something like this. And what I want to highlight here is that the bigger object is a statement object. And inside it, it has another object, which is a creator, which is a type of user. And the point is that it's a nested data structure. You have an object inside another object. Both of them are resource types defined in our APIs, but they're nested inside each other. And this is a problem for Flux, because in Flux, you basically want to have one store per resource type in your API. It makes things a lot easier if you have a statement store that only deals with statements, and you have a user store that only deals with users. But when you have data like this, it makes it hard to distribute the data to your stores. So we go through a step that normalizes the data for us. We use a library called Normalizer, linked here, that just extract each resource type, each instance of each resource type into a separate object so that you can distinguish them and handle them separately. So you have the users in one place and the statements in another place. But it also does another thing. It replaces the nested data structures with references. So the creator, oops, wrong button. No. Sorry. The creator that was a full nested object over here is replaced with its ID only. So this means that the statement store will not also store the user data that the user store already stores. It only stores a reference of the user that's instead stored in the user store. So the normalized steps just takes care of prepping the data for us into a format that's very easy to use with Flux. Because now when we have this format, distributing the data to the stores is super easy. We basically just trigger one specific API response distribute action per resource type. So one for users and one for statements. And each of our stores are just hooked up to listen to the kind of resource types that they're interested in. So our user store automatically picks up this event when we detect that we got a new response that contained users. So why this is awesome is because if we have this kind of pattern set up and we call the requests that each page component declared that they needed to have executed before rendering that page, the data will automatically flow into our stores, and we can just render in React and snapshot the data, and everything works automatically. And I think I have to show you what I'm talking about. I put a summary slide here, because I know I've gone through a lot of things, and perhaps quite quickly. And perhaps it's not all as clear to you as it is to me. So the steps we go through when rendering React isomorphically on the server is we start with when the server starts, we start all our stores. So they're ready and prepared to listen for the data that they need. After we've identified what page we're going to render, we look at its own request for props method, and we execute all the requests that the page declares. And on the server, we execute those requests synchronously, or we wait for all of them to finish before we go through and render. The data needs to be distributed to our stores, but with our setup, that happens automatically. Once the data is in the store, we can render to string with React in the very same way as we would do on the client, because all the components can use to request the data from stores as they do in a Flux pattern. And once we've rendered, we snapshot the stores to preserve their state, and we create this render context JSON that we're going to pass along to the client. We send the HTML to the client, and then, don't forget, we need to reset the stores. And if you're using something like Node, the last 5 steps need to happen synchronously, so you don't mess up the next request while dealing with the current. But that's a side note. On the client, the steps is really easy. You just parse this render context that we passed along. You start the stores, you store them via snapshots, and then you render, and off you go, and you're ready to run your application client side. isomorphically. So the overall summary. Fetch your data before rendering React. Co-locate your data request with component logic rather than somewhere else. It's just way better. You need to bootstrap your server render context to get the full benefits from Isomorphic React. And all your stores need to have snapshot, reset, and restore methods. And optionally, you can use a pattern like ours to automatically distribute request data to stores. So that's the full flow. And I hope it makes sense to you. I hope you don't find it too complicated. It's small, isolated parts that each of them are not too complicated to implement or to make use of. And a last point to make here is that we don't have complexity in our application just because we use React isomorphically. When we write a new component, we write it in one place. We write code in one way for the server and the client. There's no if-else statements. It's just simple. And the same when we declare a new route, when we declare a new API endpoint, when we do whatever. We don't have complexity because of this. It is all manageable. And I hope you've learned something, and I hope you all go forth and conquer and implement React isomorphically where you work in your projects. That's all. Can I say also, before we go to questions, if there's something that I didn't cover in this talk, please just come up to me afterwards. I'll hang around, and I can answer more technical questions. And I also wrote a blog post based on this talk. So if it was something I went through a little bit too quickly, you can go and check that out afterwards. And my slides are also on my Twitter. OK.
Thanks. So if you load a page once and then hit refresh, is it going to be faster?
Is it going to be faster if you
refresh the page
after you have rendered it on the client?
On the server. So you load the page on the client, and the server renders it. And
it will be faster, yes. Can we try to achieve that? I mean, if we cheat and throttle, we might achieve something to a better effect. Do we have a laptop, notebook? I mean, this is just a live demo. I have no idea if this is actually going to be quicker or not. So what are we comparing? This is server refresh. I mean, images are a bit slow. But images are kind of, we got the main content in the original DOM, so it was there straight away. And sure, with the 2G bandwidth, it's going to take a while to download all the images. But let's just get the comparison. What's the fair comparison? We reload this without throttling. No, we can't do that. We go to another page, this page. We clear our cache. Then we throttle. And we go client-side to the Explore page. OK, I don't know. Live demoing, it's always difficult. But I mean, it will be faster, yes. Trust me.
Thanks.
Or test it yourself. I can give, if you get back to me, I can give you some more reliable tests to show you.
Hi. Do you have a good name for this pattern? Like, we got progressive enhancement and single page applications. And I've not heard a name for a pattern of doing isomorphic single page applications that are kind of HTML first.
But I think you won't be aiming to use isomorphic JavaScript if you don't have something like a single page application. Or I mean, if you don't intend to set up a complicated, rich web application. If you just have static content, then you would not even consider this. You would just render static content. And when you do it isomorphically, I think it always makes sense to do it HTML first, at least in my opinion. So I think this is what isomorphic JavaScript is. I think this is what people mean. I don't think there's a special. I haven't heard of any special term to distinguish what I'm talking about from any other mainstream isomorphic JavaScript. If that answers your question.
What kind of router are you using?
What kind of router?
Router, yeah.
We do use a router called Director, which is an isomorphic router, but we are actually moving away from that router because we found some issues with it. I can tell you afterwards if you come up and ask me.
Hi.
Hey, so how would Flux handle partially joined data, like in that example with, what was it, statements and users? But if the user data, which was the joint data, were just partial data, it didn't contain the complete resource, and you already had a user store, how would it handle it?
I guess that's not an issue we've run into with our API. But I guess it's up to you how you want to handle it. You could, I guess, pass in a partial.
Well, I'm like, for instance, say you have yourself as a logged in user. You already have a user store, and it already contains you with your ID. But say the way it's done on the server end is it only returns partial data for statements in particular. So how would you be, like, you'd be using one store for users probably, but you don't receive the same amount of data.
So what you need is just a way to merge additional data into data you already have in a store. So if you have, we would store the partial user, the user without the logged in information in the user store, and then we would somewhere detect that, hey, we need more information. We will make an additional request. When that data flows into the user store, it would see that, hey, we already have something with this ID, and we would merge the data.
Oh, so it should be manually handled by us. This isn't something that React Flux does for us.
Flux is just a pattern. Flux does not handle this for you, but upcoming Facebook technologies might do so. Not that I know, but it's possible. But Flux would not handle that for you automatically, no.
All right, thank you.
To follow on from that question, I wondered why wouldn't you go with a subscriber publisher in particularly for your application where it's sort of like a chat and commenting system, so you want a differential similarly to what he's asking, but a publisher subscriber system with a time series to know where you are and then to get the data relevant to your topic, for example.
I think perhaps we have not looked at every possible implementation of handling data for our application, but since we adopted React and we find React to be a really good solution for our view layer, for our UI problems, we wanted to try out Flux for what it was worth to handle the data with Flux. It's possible that other ways of storing the data are better, but yeah, we haven't tried every possible method. Flux does work for us.
Hi.
Sorry, where? There, yeah. Hey.
I was actually really surprised by the amount of people that put their hands up at the beginning about the fact that they're using isomorphically rendered React applications. Is it possible for us to retry that experiment? But don't put your hand up if you are a Facebook employee. Because I was genuinely surprised. So can you put up your hand if you do have an isomorphic React application but you don't work at Facebook? Ah, right. So it's still okay.
But you know, I considered splitting that question into two because I think there are two questions. Do you render to string without data, without stores, without any kind of complicated application state, or do you render with something like this? But I don't know. I think it's changed the last few months. I think when we set this up first a few months ago, like this is why I came here, because we couldn't find any answers to any of those kind of questions. It was just empty out there. We had to find our own answers. But now I think in the last month or last few months, a lot more people have shared their experiences, and it is becoming easier and easier to do these kind of things. There are more frameworks coming up as well. So yeah.
Hi. So given what you know about what's coming with Relay and stuff like that, how much of the work which you've done now is useless or made redundant, or how much of it has been covered by new technologies in the pipeline?
That's a very, very good question. We're super excited about Relay, actually. I don't know if you know, guys all know about Relay. I'm disappointed that no one's talking about Relay, to be honest. Relay looks super exciting, and Relay seems to attempt to solve many of the same problems that I described over here. So it's quite possible, if Relay works out well, that we will switch some of these implementations over to Relay if Relay works out well. But I am a little bit worried that I don't know how Facebook is going to solve that problem, touching so many parts of your web stack at the same time without doing it, without forcing upon you a specific implementation, without saying that, oh, your API has to be like this, or oh, you have to use this. I don't know. So I think definitely in the future we will move towards using some of the parts of Relay, but perhaps not all of it. It depends on what happens. But we are excited about Relay, definitely. OK.